Okay, we talked about most of the Pig Latin commands that you might actually use in our previous example of finding old but good movies, but just for completeness, let's talk about all the other commands that are in Pig Latin. It's actually not that big of a list. So even though Pig Latin is a whole new language, you don't have to feel too intimidated about it, because there's really not a whole lot to it. We already looked at load for loading up a bunch of data into a relation already. You can also use store if you want to write that to disk. So load is used for reading, store to writing. And that is something you'll use pretty often, so I actually put an example of that here. So the syntax would be like store, the name of your relation, into whatever file name you want to save it into. And if you want to use some sort of delimiter apart from a tab, you can say using pig storage, whatever your delimiter is. And we'll look at some other storage classes you can use as well. You can also write things out to JSON or whatever you want, Parquet. There's a bunch of options there. So, obviously if you're in production, you're probably going to want to write your results to a file somewhere as opposed to just dumping them out to, the console. That's not going to be terribly useful, right? Seen dump before. Filter, we've already used that too for just filtering things out in a relation based on some Boolean expression that you set up. Distinct does what it sounds like, gives you back the unique values within a relation. For each generate we've looked at, basically a way of creating a new relation from an existing one, going through it one line at a time and transforming it in some way. And then we have MapReduce, which was actually lets you call explicit mappers and reducers on a relation. So, you don't have to choose between pig and MapReduce necessarily. You can actually blend the two together, which is kind of cool. Stream is also used for extensibility. You can actually stream the results of pig out to a process and just use standard in and standard out, just like MapReduce streaming does. And sample can be used to create a random sample from your relation. Be careful if you're doing that with a join, because obviously if you're doing random samples and then trying to join two relations together, might not work the way you expect. Now I'm kind of going through these quickly, and that's on purpose. We don't really have time to go into examples on every one of these, but I just want you to know that these functions exist and keep them in the back of your head in case you ever need them. Join we've looked at before. CoGroup is just a variation of join. So whereas join puts the resulting joined rows together into a single tuple, CoGroup actually creates a separate tuple for each key, and it creates sort of this nested structure. So it's a little bit more organized than what join gives you. So you have the choice there between the two. Obviously a single tuple is going to be a little bit easier to deal with from a coding standpoint, but if you really want that structure, CoGroup can give you more structured data from a join. Group we've looked at before is just a way of glomming together all the different values associated with a given key that you want to group by. So basically doing a reduce, right? Cross, that lets you do all the combinations between two relations. So for example, this is also called the Cartesian product. A good example of using that would be if you're creating product similarities or something like that, where you need to evaluate every product in the catalog against every other product in the catalog. You might do a cross to actually get that resulting relation of the larger matrix of every combination of products. Obviously these things can blow up quickly. Cube is even bigger. That can actually take more than two columns and do all the combinations between them as well. So not very widely used, but it's there if you need it. Order we've done, just a way to sort a relation that you have. Rank is like order, but instead of ordering it, it actually assigns a rank number to each row. So it doesn't actually change the order, but it gives you a rank for each line. Limit, this comes in handy sometimes, especially while debugging. So it's a way of just taking back the first n results from a relation. So if you're just experimenting or debugging something, you can say, limit whatever your relation name is, 100, say, to get back the first 100 rows. So, if you don't want to dump the entire thing out, you can create a new relation using limit and then dump out the first, however many rows you want to look at. A little bit easier. Union does what it sounds like. It takes two relations and squishes them together. Split does what it sounds like. Takes a relation and splits it up into more than one relation. Moving on. Diagnostics. We've looked at describe already. It's a way of just printing out the schema of a given relation so you can see what pig thinks is inside of a given relation, what the names are and what the types are. Explain, it's very much like a SQL explain plan, so it can actually give you a little insight into how pig intends to actually execute a given query. And illustrate goes even further in that it actually takes a sample from each relation and shows you exactly what it's doing with each piece of data as you go. So if you need to get more insight into what's going on under the hood with pig, explain and illustrate can do that for you, and describe can tell you what exactly is in a given relation at any given time in terms of its schema. UDFs, user-defined functions. Again, I don't want to go into depth here because this involves writing Java code and making jar files and all that stuff, but I'll point you to some resources if you do need to use this later on. These functions are for managing user-defined functions. So register basically says, I have a jar file that contains my user-defined functions. Please import it in. Define assigns names to those functions so you can actually use them within your pig scripts. And import is used for importing macros for pig files. So you can actually have reusable bits of pig code that you save off as macros, and you can import those macros into other pig scripts. So it makes it a little bit easier to reuse code when you're using pig versus, say, MapReduce. A few other things to go through. We looked at AVG, average, for computing the average of a bunch of stuff in a bag. We can also use concatenation, count to count up how many things are in a bag, max to get the maximum value, min to get the minimum value, size, and sum. Sum just adds it all up. And lastly, we have different storage classes here that we can use. So we've looked at pig storage, which just uses field-based data. So this assumes that you have some sort of delimiter on each row of your input or output data, and that can be configured to be a tab or anything else that you want. Text loader is even more basic, so that just loads up one line of input data or output data per row. So you can have a row of just a big old blob of text, and then you can do what you want, kind of like what you do in MapReduce when you're doing your first mapper, right? But you can also use more structured formats like JSON. Avro, we haven't really talked about Avro yet, but that's a data format that's, more specifically a serialization and deserialization format that's very popular with Hadoop. It's amenable to having a schema and also to being splittable across your Hadoop cluster. So you might come across Avro files from time to time. Parquet, another popular data format. It's a column-oriented data format, and we'll talk about that later in the course. Orc storage, also another popular compressed format. And finally, HBase storage. So you can actually integrate Pig with HBase, which is a NoSQL database that we'll talk about later on as well. That's part of the Hadoop ecosystem. And there you have it. If you want to learn more, like I said, we don't have time to go into all of these. I just want you to know these functions exist. But there are some very good O'Reilly books out there if you want to go into more depth. Programming Pig is one of them. And if you want just more of a high-level overview of Pig, there's a chapter on it in the book Hadoop, the Definitive Guide, also published by O'Reilly, which is a great book that I highly recommend. So there you have Pig in all of its glory. And up next, I have a little challenge for you. Let's show what you know and put what you've learned about Pig into practice. We'll do that next.